Ladies and gentlemen, welcome to this TEDx event and to the Technology and Innovation Centre. As the Lord Provost said, the great excitement we have in the city is for COP26. Perhaps what is not so widely known is that Strathclyde University is hosting the Conference of Youth here at the end of October, which I think is going to be should be at least as energetic as COP26, and it'll give us that starting point where the youth of society will challenge people like me and my generation to make things happen, and I think that's the point I want to make today. My proposition for you will be that we can't deliver a decarbonised future without engineering and taking a systems approach. And I'm an engineer myself, but I make no apology for that. This is a technological university, but a technological university isn't just about technology. It's about policy, economics, engaging society. And I want to give you a sense of the pathway to 2050, because as we've talked about in the title of this conference, resilience is everything. But I want to have you perceive that resilience in the context of you as components of a system. This city is a large, complex system, and you can imagine, and I'll do some multi-scale here. I'll think about cities, I'll think about us as citizens, and I'll think about us in a context of a national and international scene. Because in many ways, if we think about decarbonising energy, which is a critical part of us challenging this wicked problem of the 21st century, climate change, global warming, the impacts that we've had from COVID over the past 18 months demonstrate the interconnectivity, the dependencies, the risks, but the opportunities. And as the Lord Provost was saying, the uplifting sense of us influencing the future. Who knew that we could get vaccines designed, developed, deployed, manufactured and out there in such a short time? And COVID, when we reflect in the coming years, we'll see as the biggest accelerator we've had in generations for digital transformation. We talked about it, whether it's Zoom, Microsoft Teams, how we engage, and it'll also be a driver for decarbonisation. We've started to see that we can decouple productivity from travel. Now, that will never displace the social engagement of us meeting together, and it is a great pleasure to have colleagues back in this conference room. But I want us to think about resilience, I want us to think about future, but also, as an engineer, I want us to see the practical pathway to delivering a decarbonised future. We often talk, again, let me give you a first comment about systems. The trilemma in energy has been understood for some time. That is the competing pressures of decarbonisation, about affordability and reliability and resilience. So what does that mean? If we go all wind energy, which I'm a great proponent of, but that gives us an issue because of intermittency, and it's been rather expensive until recently because of technological innovation, government intervention to create new markets. We've reduced the cost of offshore wind by 2/3 in under a decade. Incredible. Technological advance, a vision for a future, and the other piece that's very often underplayed, leadership and consistent policy making. So there's a system already. Engineering and technology for offshore wind, policymakers that understand that they've got to create a facilitating environment within which technological innovation can take place, and then the real magic element, and that's people deploying and then using renewable energy. So the trilemma of affordability, decarbonisation, and reliability is complicated by what I might call the quadrilemma, and that is public acceptability, public engagement, and people's behaviour. And if we don't factor that in, then we won't achieve that decarbonised future. We need people to engage. And I speak about myself as a citizen. I have to be responsible about my consumption patterns, about the transport that I use. And I'm happy to say at the end of the year I'm going to transition to all electric vehicle. And so I should. There's a whole issue there, of course, about a just transition. And we need to make sure that those that need to can also afford to use decarbonised transport. And it's not just the advantages of those that can afford these new products and systems. And as an engineer, if I really destroy the English language, there's the quintilemma as well. And that's reliability, cost, decarbonisation, people, and other pieces, economic opportunity. A friend of mine, Lord Nick Stern, who's an eminent economist at London School of Economics, wrote the eponymous report, the Stern Report, and I commend it to you, about the economics of climate change. He wrote that 15 years ago, and some wonderful scenes with him standing alongside Al Gore, talking about the proposition, about the need to have a just transition. So industrialized nations such as ours have the wherewithal, but we need the focus and delivery, but we need to bring the developing nations with us in a partnership mode, respectfully, and also helping them develop opportunity. And that economics piece here is, let's build new industries. As we decarbonise the hydrogen economy, let's think about what that means for creating new companies, new industries. Offshore wind, I published a report on a commission I took from Scottish Government about 9 months ago. I published it last month about wind in Scotland. Now we've got lots of it, and we've got lots of wind being deployed, and we've got high tides, and we've got strong, and high waves, but we haven't captured the economic value. So my proposition is that as we go now, and I know let me flick between Scotland and the UK, Prime Minister last November laid out his 10-point plan for decarbonisation, one part of which was by 2030 to have 40 gigawatts, 40,000 megawatts, which represents about 80% of the UK's peak demand, deployed in offshore wind. Fantastic. And to do that in 8 years is a big challenge. But let's do it and create more jobs in Scotland, in the UK, and by engaging communities. So my proposition is that floating offshore wind, which allows us to get the wind captured maybe 20, 30, 40 kilometres offshore, and these structures, by the way, are beautiful for an engineer. Advanced materials, there's an expert here in composite materials in the room today. From sea surface to the top of the top blade, 300 metres. That's something like a 220 metre wingspan, having to cope with high winds, but out there, fantastic wind quality, great yield, and then back to the systems point. Okay, so if I get out there, I can't anchor it to the seabed because it's maybe a couple of thousand feet deep, so I need floating platforms. Right, so I can transition subsea capability from oil and gas, and oil and gas are making a commitment to their energy transition. They're often accused of greenwashing, but let's show them the trust that they really want to make that journey to decarbonising. So subsea engineering, offshore services, let's get them involved in designing and building offshore platforms on which we can float turbines. And then what else can we do? Well, as well as bringing electricity ashore, we now need a subsea DC grid. So the grids that you see marching across the countryside on pylons, we now need to imagine that under the sea, so that we've got this interconnected UK, Northern Europe, Scandinavia, and Southern Europe connection. A continental grid system, a really interesting approach. And what we might want to do, because hydrogen and ammonia are great energy vectors, let's make that gas out at sea, and then we can have autonomous, decarbonised ships that go out, pick up the gas, bring it ashore, and make things happen. So you can see the systems perspective in that, and that's what we need to think about as engineers and as society. In January last year, 2020, the Prime Minister's Council for Science and Technology, which I have the privilege of sitting on, made a rather, a respectful but assertive note to Cabinet Office that in order to decarbonise the UK, now the UK has made a legally binding commitment to decarbonise by 2050. The Scottish Government, if you let me scale up and scale down, has made a legally binding commitment to get there by 2045. This proud city is making a commitment to get there by 2030, and that's an eye-watering challenge, but you need that political leadership. But the CST, Council for Science and Technology, said you will only achieve this, Prime Minister, and in my ways, speaking with our First Minister in Scotland, we'll only do it by taking that systems approach. And I'll give you some examples of that so that we don't stay in the concept and we get more to the practicalities. So, for example, we have to start making that journey to a future power system and transport as well. What's it going to look like? Well, the Energy Systems Catapult in the UK did some great modelling last year, and they have to, we have to think where we're trying to get to. As a colleague of mine at MIT used to say, Jim, the forecast is always wrong, but at least you have to have scenarios that allow you to play out what it might look like. And in the scenarios, electrification is a massive requirement, digitalisation, a strong underpinning. And in the modelling, we're saying in the UK alone, we may have to double the number of electrical generation systems that we've got in the UK. Now, because I'm taking a systems perspective, think about this, we're going to be out of coal, i.e. out of coal generation by 2024, 25. So there's a pressure. We've got aging plant that has to be replaced, and we've got a massively increasing demand for electricity. So we need a systems architect to imagine what it's going to look like. So we need double electricity. We need to think about bioenergy coupled with carbon capture and storage. And that is a technology that the UK should, academically, we're well ahead of the world. We haven't got to deployment. So back to that system. Government needs to say we're going to back these activities. We'll show it in offshore wind. We need to do it in carbon capture and storage. Let's help oil and gas get carbon out of their systems. And some wonderful, you probably heard about blue hydrogen and green hydrogen and purple hydrogen is appearing now. Rainbow hydrogen, I love the idea of that. But green hydrogen means that we take the power from renewable energy, e.g. these offshore winds, and through electrolysis drive hydrogen. Systems engineer. So what do we do with the hydrogen? How do we transport it about the place? The natural gas system we've got could well be fit for purpose, but there may be some metallurgical issues that we have to overcome. So I need to start thinking about advanced materials and how that connects to research. But if I can get the hydrogen, how do I best use it? Do we want to use it for decarbonised heat just now? Probably not, but we do want to use it for high heat applications in industry. So then we need to play in the industrial designers. How do they imagine the next decade where they're using hydrogen as a fuel? So there is hydrogen, we must do that. Blue hydrogen, by the way, is a big opportunity. In Scotland, up in Aberdeen and St Fergus, where the oil and gas comes ashore, let's apply steam reforming. Let's strip the hydrogen out of these hydrocarbons and then feed that into a hydrogen infrastructure. But you can only really do that effectively by taking a systems perspective. And I'll give you a very topical example of a system in unexpected interdependencies. This fuel supply crisis that we've got is a big issue. And it's confounded because of what's happened in the past year. Because of COVID, we had the shutdowns internationally. COVID now being managed, we're seeing economies starting up. So the demand for gas is going through the roof. At the same time, 9 months ago, we had a pretty low wind year. So the large wind infrastructure wasn't generating as much as we thought it might get, so we used more gas. So we depleted the gas storage. There have been problems with Russia supplying gas into Europe, and some of the gas platforms in the North Sea were out for maintenance. Now, that is a pretty difficult convergence. And then you think, well, we never anticipated the fertilizer plants then would shut down because they couldn't afford the gas on their business plan, which meant we didn't have CO2 for the humane dispatching of livestock or gas for other industrial applications. So you can see a domino effect. And I could go on about, you may remember the ship that got blocked in the Suez Canal. The ripple effect into international supply chains. Now, it doesn't mean to say that unintended events don't happen, but we need to have resilient infrastructure, to the tone of this conference. So we need to have a resilient infrastructure, a systems perspective of how these things interconnect. And that's why the UK now, in its commendable journey to a decarbonised 2050, has to think about interaction. And it's not just technological interaction. We need policymakers to act in a very much more integrated way. UK government, like most other governments, have very strict departmental silos, which means they don't talk to each other enough. They don't recognise the interconnectivity. So systems thinking, which has been fantastically well advocated by Sir Patrick Vallance, whom I'm sure you've seen, who often speaks to us nationally, Patrick and Chris Whitty, our Chief Scientist, our Chief Medical Officer. As President of the Royal Academy of Engineering, I've been speaking to Patrick a lot about that systems perspective, and he gets it and has become a relentless advocate for systems thinking. And I want you to take that out of today's talk. Think systems, and don't be overwhelmed by systems, because you're part of the system. And the system is an aggregate of all the actors. So what you do about consumption, your transport, how you apply your own behaviours, aggregates up 65 million people in the UK, 7 billion people plus in the world. Individual actions aggregated up makes an enormous difference. So think systems, and also think engineering, because the engineers will help us get there. And Scotland's been thinking about this for a while. To their credit, a friend of mine, Chris Stark, who's the Chief Executive of the Committee on Climate Change, was the Director of Energy and Climate Change in Scottish Government. And with input from myself and others, he proposed the energy systems approach in Scotland. So we need to remember that ourselves, promote it. And we said, what about the interconnectivity between energy, transport, and heat? In Scotland, in end use, and you're starting to feel it, those of you visiting us maybe for the first time, about 53% of our energy goes into heat. I think maybe we should increase balaclavas, gloves and scarves maybe as an offset to that energy requirement. But 53% for heat, about 23% for transport, and only 22% for electricity. So we need to think about that and decarbonise. And the Intergovernmental Panel on Climate Change have given us a stark reminder. 1.5 degree temperature rise above pre-industrial levels is already a challenge for us. We talked about 2 degrees. Now we're talking about 1.5 degrees before we get catastrophic effects. And we can see that population movement, civil unrest, firestorms in America, flooding. We have no option here, colleagues. We've got an existential challenge for the 21st century, and we've got a requirement here to work as a system. So let me go to a few concluding remarks. There's lots of technological opportunities here, and for an engineer in the technology, it's a Pandora's box, but there is no silver bullet. We need get oil and gas on its energy transition. We need lots of wind. We need solar, and solar works in Scotland as well. That's a good thing, but we need to see it from a systems perspective. And that future of bioenergy, carbon capture and storage, and nuclear, and I don't have the time a lot to talk about nuclear, but we need the next generation of fission reaction. But fusion has been tantalising for 50 years. When I was an undergraduate in this university, fusion was 50 years away. As a 60-year-old man, fusion feels like 50 years away. But now we're getting some real drive here. The Joint European Torus project, it's quite exciting for me, it should be for you, STEP, the spherical tokamak reactor for energy production. There's £250 million investment competition that's underway where the UK can become a leader in fusion power. That is a big opportunity for us. And also follow the money. When you see Jeff Bezos and others now putting their money into fusion nuclear reaction. But between now and then, we'll need to do other things. And one way to do it is, for example, small modular reactors, safely run and fed by how we power naval ships. So the future is very bright. And I know that because my 3 kids are engineers. One of my daughters involved in leading net zero or energy transition for Deloitte. My other girl heads up smart grid for UK power networks. And my son, who always had to keep up with his big sisters, is working on the smart grid for Scottish Power. So it's not that engineers rule the world, but you need engineers to make the world work better. Let me conclude. You're in a city, and cities make a difference. Bear this in mind. Cities produce or require 75% of the world's energy, and cities produce about 80% of the world's greenhouse gases. So the design of cities, the operation of cities, and the behaviour in cities will make a difference. And we need to think about how we roll that out. So my concluding remarks, think systems, think about the complex interaction between engineering and technology, policy, economics, behaviour, and economic value. My quintilemma digested down into a trilemma, but that in itself sits within a system. And don't be overwhelmed by it. My last anecdote is the grid that I've talked about a few times. Another Scotsman, Lord Weir, to give you a history lesson, Lord Provost, because I know you're a historian. Lord Weir, a very famous person in Scotland, was commissioned by the British government to do a review of electricity supply in 1926. In London, at that time, there were 12 different frequencies, 15 different voltages, and he proposed, rather beautifully put, the creation of a national gridiron of electrical connections, hence the grid. He conceived of that, the Electricity Supply Act was written, and now in 2021, we need that same concerted effort of entrepreneurial spirit, technological excellence, policy commitment, and an exciting vision for the future of a decarbonised society. which has within it a just transition for all. You're part of it, individual citizens, your influence between each other, your excellence in terms of your professional activity will make a difference. And let's tell the story in an upbeat way. And rather than wringing our hands a lot, and we've got a lot to wring our hands about, let's smile, let's work together, and let's see a decarbonised future for 2050. And through that, we'll have a resilient, decarbonised system. Thank you very much.